Welcome to grayyeonmath. We are asked to solve this problem. We have a semicircle, and it is given that the semicircle has has a point which is tangent to a side of this given rectangle ABCD at point G, and a secant AE is drawn, which its endpoint A is perpendicular to the side of the rectangle. And another secant is drawn, ED, which passes through the center of this semicircle. And we have here another line BF, which goes from the topmost vertex on the drawing, or topmost vertex of the rectangle downwards to the right side of the yellow semicircle, and it is perpendicular to the secant ED, and the measure from point A to point of tangency at G is 10, and from the point of tangency at G to D is 15. And we are required to find the area of the blue rectangle. Okay, so first thing that we need to consider is that uh, this point of tangency, we can actually draw a line that passes through the center of the semicircle, and this will be, of course, the radius. And next is we draw another segment which will be perpendicular to uh, a AE from the center of the semicircle. And if this is point of tangency, then this should be 90 degrees. And if that is 90 degrees, then we form here an angle. Let's call this angle as alpha, and this is beta. And since we have drawn a perpendicular line, the second line that we draw, perpendicular to this secant AE, and that is perpendicular. And at point G also, this is 90 degrees because of the point of tangency. The other uh, angle is 90 on the right, and this should be also 90 degrees because since it is a point of tangency, it forms a straight line and perpendicular to this radius. And if that triangle is 90 A and G, then this center has an angle of 90 degrees also. And if that is 90, then this angle should be a complement, and we call this beta. And this, we call this alpha. Because in between this beta and in between this beta and alpha is a 90 degrees. So this should be beta and the other is alpha. And this should be a 90-degree angle. Okay, so next is we focus on these two triangles. I will shade this as the red one. This triangle, this small. And this, let's say this as another color, green. This triangle. Okay, these two triangles are actually similar because as you can see, they have the same angles inside the 90-degree angle and the alpha and the beta. And therefore, they are actually similar. And next is we label this from point E to the center as the radius. So let's call this as R. And this from the center to F is R. And let us call this from F to D as X, and this as R, and this length is also 10. So this is 10 units. Okay, so I forgot to mention earlier that our goal is to find the area of this rectangle. And since we are interested in finding the area of that rectangle, then we are only uh, needed to or required to get this length AB. So, because as you can see, the length is actually given, which is 10 plus 15, the length, which is subdivided into two parts. So, the length is already 25, and we are, of course, to get the value of AB, which is the width of the rectangle. Okay, so going back, so comparing these two right triangles, the similar right triangles we have. So we can actually focus on the angle beta. So for the red triangle, so if we focus on beta, the let's say we have the adjacent as 10. So adjacent is 10 over R is equal to, for the green, so we have 15 over R plus X. So we can cancel this. They are divisible both by 5. So this becomes 2 and this becomes 3. So we have, if we cross multiply, we have 2 times R plus X is equal to 3R. So 2R plus 2X is equal to 3R. So 3R minus 2R. So 3R minus 2R is equal to 2X. So R is equal to 2X. Or we can simply say also that X is equal to R over 2 if we divide both sides by 2 or multiply by 1/2. So X is equal to R over 2. Okay, so next is I want you to notice that on this circle, this larger a circle or triangle, this larger triangle has already complete details. So one leg is R, the other leg is actually 15, and the hypotenuse is the sum of these two lengths R and R over 2. So if we compare that on this other triangle, this smaller one, so it has a missing detail here. So let us find this length with respect to this uh, the ratio and proportion of this larger right triangle. So if you try to focus on angle alpha, this angle alpha for the small, so alpha, focusing on uh, adjacent over the hypotenuse. So for this smaller, let's call this as y. So y adjacent over the hypotenuse r. So y over r is equal to the ratio for this triangle. So the adjacent is r over uh, this is actually r plus r over 2. So we have to make this. y over r is equal to r over 3 over 2r, or let's make this understandable. So we have here 2 divided by 1 is 2 times r, which is 2r, plus 2 divided by 2 is 1, okay, times r is r. Okay, so we have y over r is equal to r over 3r over 2. And we can simply cancel this r. And these 3 halves reciprocate, so this becomes 2 thirds. 2 thirds. And if you cross multiply this r, multiply the r on the from the denominator of the left hand side, so this becomes 2 thirds of r. So y is equal to 2 thirds of r. So we can replace this y with this y is 2 thirds of r. 2 thirds of r. Okay, so notice that this length is also r because it is parallel and have the same length as this length. So that is also r. And again, we take note of the fact that for the angle alpha, the adjacent side over the hypotenuse is equal to 2 thirds of r over r, and that is equal to 2 thirds for the ratio of uh, for alpha adjacent over the hypotenuse, that is 2 thirds. Okay, so next is we focus on the big right triangle BFE. Okay, so for BFE and focusing on the angle alpha, so for the angle alpha, adjacent over hypotenuse is 2 thirds, and it is equal to uh, for the that biggest, it is because it is the biggest in the figure. So we have EF adjacent over BE. Okay, so 2 thirds is equal to 2r because this is the length of this is the adjacent side, so 2r over the unknown. So let's call that BE. Okay, BE. Okay, so we can cancel these two and we cross multiply. So we have cross multiply, so BE, and cross multiply this. So BE is equal to 3R. Okay, so next is, since we have the value of BE in terms of R as 3R, and we also have this AE as 2 thirds R plus R, so we can actually get the value of AB. So AB, AB, AB is equal to BE minus AE. Okay, so AB is equal to BE, which is 3R, and AE is equal to the sum of 2 thirds of R plus R. Okay, so AB is equal to 3R, copying that, and we have the LCD as 3 divided by 3 is 1 times 2. So 3, that becomes r plus 3 divided by 1 is 3 times 3r. Okay. So we just need to simplify this inside. So we have 5r over 3. So 3r minus 5r over 3. So AB. So LCD again is 3. 3. So 9r. 3 divided by 1 is 3 times 3. So 9. So minus 5r. So AB is equal to 4 thirds of r, because 9 minus 5 is 4. So 4 thirds r. Okay, so next is we are required to find the value of r, because we only have the lengths in terms of r, and we need to get the r because we need a numerical value for the area later and the lengths. Okay, so in our case, if you focus on these two I mean the secant segment and the tangent segment. So GD, GD, and ED. We can actually use the tangent-secant theorem, okay, to find the value of R. So you can see that the segment ED is the secant segment and the segment GD is the tangent segment. So for tangent-secant theorem, we need to square the tangent segment. So that is GD square is equal to the product of the whole secant segment, and that is ED, multiplied by the exterior secant segment or external secant segment, which is FD. Okay, so GD square is equal to 15 square, and ED is equal to 2R plus R over 2, 2R plus R over 2, and FD is equal to R over 2. And 15 square is 225 is equal to, this becomes 2 divided by 2, divided by 1 is 2. So this becomes 2 times 2. This becomes 4R plus R over R, still R. So we have here, copy this R over 2. And this becomes 5R. So 5R times R is equal to 5R squared over 4. It's equal to 225. Okay, so next is we divide or cross multiply. So R squared is equal to 225 times 4 all over 5. So if you divide this by 45, this I divide by 5, 225 over 5, this becomes 45. And 45 times 4 is R squared is equal to 180. And if we take the square root of both sides, so we have here, sorry, R is equal to, this can be written as the square root of 36 times 5. So we can simply put this 36 outside. The square root of that is 6. Square root of 5. So radius for the circle is 6 square root of 5. Okay, so now for the final step is we can now find the area of this rectangle. So area is equal to AB times AD. So AB is equal to 4/3 of R, yes, that is the width, and multiplied by AD, which is 10 plus 15, and this becomes 25. So 25. So, but R is 6 square root of 5, so we can simply substitute that. 4/3 times 6 square root of 5 times 25. Okay. So, we can actually divide this by 3, so this becomes 2. So, this becomes 8. So, times 25, or shall we say 4 times 25 is 100 times 2. So, 200 square root of 5 square units. And that is our answer. So thank you for watching until the end of the video. Please like the video if you like our solution, and don't forget to subscribe to the channel and hit the bell icon so you will be updated for more math videos like this. Thank you. Bye.